Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about infinite geometric series. Okay, so we're going to take a look at the series. These are the terms, outputs, 1, 4, 9, 16, 25, 36. So input 1, output 1, input 2, output 4, input 3, output 9, etc. So I want you to think about what the function rule is. As the number of terms goes to infinity, what happens to the series? And then does the sequence converge or diverge? So again, we're going to differentiate between sequence and series. Remember, the series is the sum of the sequence. Sequence is just the listing of the terms, inputs, and then outputs as terms of a given rule. So I'm going to pause here while you figure that out. All right, so you should get the rule is n squared. The sum of the series is going to be infinity. And then the sequence diverges. Remember, we said that the sequence diverges if it approaches or goes to infinity. So it diverges. All right, so let's take another look at another sequence, 1, 1/2, 1/4, 1/8, 1/16. And you can see that this is a geometric series, so there's a value for r. So I want you to figure out what the function rule is. What happens as it goes to infinity, and does the sequence converge or diverge? Okay, so you see that the formula is 1/2 to the n minus 1. And again, you could write this using the rule for explicit rule for geometric series. And then if you type into your calculator, and you can do this as a practice, 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, you'll see that the sum is approaching 2, and you can see that pretty clearly on your calculator. So this the series is equal to 2, believe it or not, and the sequence converges, and it's going to converge on 0. All right, so this is going to be a pretty quick lesson. I'm going to give you the formula. We're going to do some practice, and then we'll talk about using infinite geometric series formula to figure out what repeating decimals are as fractions. All right, so infinite geometric series formula, the sum of the first n terms, or the sum of the terms of an infinite geometric series, is called a partial sum, by the way. We'll talk about partial sums in a second. The sum is equal to the first term divided by 1 minus the common ratio, where the common ratio has to be, as an absolute value, less than 1. So a sub 1 is the first term, r is a common ratio, and the common ratio has to be less than 1. All right, so I want you to find the sum of these infinite sequences. I'm going to pause here while you figure this out. All right, so the trick is to find out what the common ratio is for each of these. On the first, it's going to be negative 1/3, so first term is 1. 1 minus the common ratio, negative 1/3, is going to be 1 plus 1/3, which is 3/4. 1 divided by 3/4 is 4/3. Number 2, common ratio is going to be negative 1/2. 1 minus 1/2 is going to be 3/2. 24 divided by 3/2 is 24 times 2/3, which is going to be equal to 16. Last one, the ratio is square root of 1 over 3, which is root 3 over 3. And then you're going to say 1. You can either evaluate this by saying 1 plus multiplying by the conjugate of 1 minus the square root of 1 over 3, which is 1 plus the square root of 1 over 3. And you end up with 9 root 3 plus 9 over 2. There's some math which I won't go through. You can evaluate this and check my math here for the third problem, but this answer is correct. 9 root 3 plus 9 divided by 2. In my class, you probably won't see anything this difficult. In a test situation, it requires you to do as much math. It's not necessarily related to finding the sum in this case and evaluating the formula for infinite geometric series. Right, if the value for r is greater than 1, then we say, or equal to greater than or equal to 1, we say that the sum, there's no sum for the infinite series or its infinity. All right, so partial sums, we'll go back to for infinite series, we're just going to find a partial sum, which means we're going to go back to the formula for sums of geometric series, which is t sub 1 times 1 minus r to the n over 1 minus r. And then we're going to find a partial sum for the geometric sequence. There's no work to do on that end. We're just going to go straight into now last part of the lesson. We're going to figure out how to create a fraction for a repeating decimal using what we know about the formula for the sum of infinite geometric series or sequences. All right, so we're going to take, and I'm going to walk you through this one. You're going to do a couple problems on your own. So we're going to ask you to rewrite 3 repeating as a sum, and it'll look something like this. 0.3 repeating is just 333.33333, etc. We can rewrite that as a sum as 0.3 plus 0.03 plus 0.003 plus 0.0003. Now we can think about this in terms of an infinite geometric series where a sub 1 is going to be 0.3 and r is going to be equal to 1/10 or 0.1. So now we have all that we need in order to figure out what the value is as a fraction for the repeating decimal. It's going to be 0.3 over 1 minus 0.1 or 0.3 over 0.9 or 1/3 if you simplify it. Okay, so think about repeating decimals as sums of values and use what you know about infinite series sums to find out what that value of repeating decimal is equal to as a fraction. This one's pretty easy. Let's give you some more complicated or challenging ones. We'll go through the answers for 1 through 4. I'll have you work these out. I'm going to pause here while you do that. Last one's a challenge question. Let's see if you can figure that one out. You have to come visit me in person to ask me the answer to that question, and then this will be it. Okay, so you should get 4/9, 4/11, 17/3, and then the last one is going to be 7 over 165. So I'll write that in here. 7 divided by 165. All right, that's it for this edition of Ott and Math. Thanks for joining us. You're going to join us next time for the last chapter section of chapter 13 when we talk about sigma notation in the next edition of Ott and Math.